Okay, so welcome everybody. Today we will be listening to a presentation of Aaron Garforth. He works for TRG Screen and is responsible for the inception, the vision and design and implementation of the Axon platform, comprising of a suite of cloud-delivered products and managed services, including the industry-leading peer. And today he will present the challenges of exchange, compliance, and how technology and AI can help.
Excellent. Well, welcome everybody. I've forgotten that bio, to be honest, so that was, yeah, I sounded more impressive than I thought I would do at this stage. So today we're going to talk about exchange compliance and dive a little bit into how we use technology to basically solve the problems, and then looking forwards into where we are going with use of AI. So first of all, quick introduction to myself. So I'm responsible for the exchange compliance offerings, which is also known as the Axon platform. They comprise PAIR, ACT, and ADS, because we really like acronyms at Axon. My experience, I spent about 12 years at the London Stock Exchange, where I was responsible for, well, various different jobs, one of which, unfortunately, was being a market data auditor. Not trying to get the entire room offside, but I spent a few years doing that. A lot of time around policy and writing policy, introducing policy, being responsible for the commercials on the exchange landscape. A bit of experience in the vendor and user community, and then co-founder of Axon Financial Systems, and we were acquired probably about 5 years ago now by TRG Screen. And as I say, continue to be responsible for that part of the business line. So first of all, really, what do we mean by exchange compliance? Simply put, complying with the published exchange rules when consuming market data. So pretty straightforward, really. Where can the complexity come in that? The reality is, there's about 4 parts to exchange compliance. First of all, you've got to be aware of the policies. You can't comply with something if you don't know what it is. The reality of our marketplace is that most clients don't have a direct relationship with those exchanges. You have to go and find these rules. You have to scour the internet. You have to, hear it from your peers and so on. You don't necessarily have that contractual relationship. You're disintermediated effectively by the vendors. Awareness of your data usage within the organization, once again, seems like it should be pretty simple. The reality, not quite the same. So you've got to track all of that usage that's going on within your organization, basically. You've got to know where the data's going. You've got to understand how it's being used. Now, as an auditor, I'm absolutely aware that people get a big pipe of data that comes into the organization, developers grab hold of it, they run off and do really exciting stuff, and the market data team are constantly playing catch up. So that's always a challenge within this marketplace. By knowing the first 2 here, being aware of the exchange policies and knowing how your data is being used in the organization, we can then actually declare back to the exchanges accurately. So obviously we have a fairly unique marketplace in that we use data and then we pay for it after the fact. So we've got to declare that usage back to either the exchange or back to the vendor. So you've got to put the first 2 pieces together to make sure that you're accurately sending that information back. And then finally, nowadays especially, we have a lot of licenses. We have a lot of non-display use. We have a lot of derived data use. Gone are the days where everything was on a terminal and it was quite simple. So you've got to try and pull all of this information together to make sure that you are correctly licensed and that everybody at the organization is paying for the data that they're using. So why is this so difficult? Well, this is a snapshot out of PAIR, basically, for how this landscape changes. So in the last year, we've seen 2,075 license updates across the markets that we cover in PAIR. We've issued 232 separate announcements, telling people that something has changed. In some cases, actually, telling people that nothing has changed. It's just that there was a new contract that was published. And rather than other people having to read it, we've read it and established that there was nothing material. 587 data charge updates. So terminal fees, obviously most exchanges are going to publish and change their prices once a year. So that one maybe not quite as surprising. The one that surprised me, to be honest, was probably this one, 73 new real-time products. That might be a little bit of a kind of an outcome of the way that we store information on Pair. It might be that we've had to update and create some new products to reflect the marketplace. But essentially, this is what the market data teams in every organization is dealing with on a yearly basis. And then finally, 56 documents that have been reviewed. So 56 contracts that we've gone through. Might be contracts, could be 15-page policy documents, could be price lists. But this is effectively the complexity that we're dealing with in this marketplace. So how did we get here? The reality is we work in an innovative industry. We provide market data, and all of the firms consuming market data, all of the vendors are constantly innovating and finding new ways to use that data. So we have to keep changing the policies. The exchanges are just reflecting the marketplace. In reality, it's quite easy to sit back and say the exchanges keep changing things, they keep publishing new documents. The reality is they're playing catch up and they're just trying to reflect exactly what's going on in the marketplace. So in terms of a timeline, back here in probably the 1990s, I guess, maybe the 2000s, everything was on a terminal. It was quite simple, right? We just had screens. It was a closed system. The vendor knew somebody was using the data, or they weren't. They declared to the exchanges. I remember when I first started at the LSE, we had a handwritten document where people filled in their declarations, which had like 5 copies of the thing on the back. And we literally took those and created an invoice. It was a very simple process. The next step after that really was the introduction of data feeds. So client infrastructure started to get more complex. We started to have big backbones that were disseminating this data everywhere. So we had a big pipe that was switched on somewhere, a big tap was switched on at the exchange, and suddenly data's out and it's everywhere around the organization. So we're trying to chase that around. We then move, well, effectively combined with this really, we move more into desktop consumption. So even the likes of Bloomberg suddenly, rather than being a terminal that was sat in the middle of a trading floor, or potentially if you were a good enough trader, a terminal on your desk, everybody had a version of Bloomberg and a version of in-house applications on their desktop. So once again, an additional complexity. Vendors then started to distribute the data on the internet. So we started to get into quote metering. We started to get into per price request. We started to get into more complex models, basically, of dissemination. So once again, the exchange policy document got a bit bigger because a vendor came to the exchange and said, I want to do this. And the exchange said, yeah, that's fine. We'll create a license for that. I want to put it on a TV ticker. Okay, we'll create a license for that. And the whole thing just keeps getting more and more complex. Derived data and the rise of terms like new original work suddenly started to come into our vernacular. We had a lot more tradable financial products. We have ETFs, we have funds, we have lots of different ways that people are taking that data and monetizing it. People are creating indices, people are creating curves. Suddenly the data is fuel. And then, of course, we get into algorithmic trading, which has probably been, I think, since we set Axon up 10 years ago. I keep referring to non-display as the hot topic, and somehow it still is 10 years on. So algorithmic trading, people taking this data, people creating algorithms, smart order routers, all of those types of things, changing the whole policy landscape. And then somewhere in the future, where in fact, to be honest, currently, I think the CME recently put out an announcement that AI is non-display use. So we can imagine that this is only going to get more complex. AI consumption of data is definitely on the horizon, if not, taking place right now. And no doubt the policies are going to have to follow and catch up. So now we get to this stage where we have all of these words, all of these expressions, all of these terms, basically, for the use of market data. Things like unit of count, things like non-display use, quote metering, new original work, non-professional usage, and so on, are now common in our vernacular. They all mean probably something slightly different to each of us, but they're terms that are used throughout the whole industry. So how do we handle this complexity? The answer, or the approach that we've taken really, is standardization. And by that, I don't mean trying to get the exchanges to all agree on one language or one template or one contract. That's never going to happen. We've got to be completely realistic. Exchanges, like every other business here, are there to make money, and they have their own drivers. So what we do is we take all of these terms, we take these contracts, and we break them down, basically, into various different elements. So the way I like to talk about it really is that we place them into buckets. There's generally only a certain number of things you can count, a certain number of terms you can tag things with. So we break all these policy terms into buckets and add effectively metadata tags. So these are examples of some of the ones that we have at the moment. So unit of count, which we'll go into in a bit more depth in a sec. Effectively, there's only a certain number of things you can count when you're counting a terminal. So these are kind of the 4 buckets that we have. Similarly, non-display usage. When you look through the contracts, whilst everybody uses slightly different terms, the reality is they're generally talking about one of these 6 or 7 things here. So you're either using it for algorithmic trading, you're either using it for analysis, to back test, or to analyze and look for opportunities. You're doing things like order pegging, smart order routing, probably bigger in the States than it is in Europe. The ones that may be slightly iffier are things like risk management, fund administration, portfolio management. They're all things that we have to do, or a consumer firm has to do. But these are all elements of non-display usage as it is set out by various exchanges. Derived data usage, I've kind of simplified it a bit here, to be honest. We have more elements than this because we consider whether you're using one instrument or multiple instruments, whether you're distributing the data internally or externally. But the concept stands that, once again, there's a certain number of buckets that you can drop things into. So in terms of a working example of that, I wanted to go through unit of count. So we have what should be, I guess, a pretty familiar setup here. We have a couple of vendors. We have the data coming into some kind of entitlement system. We have a classic Bloomberg setup, a standalone terminal. And then through the entitlement system, we have a trader who's effectively got data coming in from vendor B, feeding a couple of applications, and data coming in from vendor A, feeding one application. So, as I say, effectively, there's only a certain number of elements to count here. So for each unit of count, we'll stick with this same setup, and we'll just look at counting something different each time. So on this first example, the easiest, the most simple, I guess, is that we can count the user here. So that's the classic netting example where somebody's getting data from Bloomberg and Refinitiv, and you count the user. It's nice and simple, and we can all understand it. Unfortunately, you can't program it very easily, but there we go. The next example is what we would term user per source. So in this case, we're counting the sources of data. So we have the standalone terminal, because this is its own environment. And then we have the fact that we're getting data from vendor A and data from vendor B. So if we're talking about a DAX environment, this would be counting the max. This would be counting the login effectively and ignoring the max count. The third example is per instance. So this is where, in a DAX type environment, we would be counting the max counts effectively. So I would need a login here that would give me 2 concurrent accesses, a login for this one, and a login here. So we get a per instance count of 4. And then our final example is actually a NISE special. I don't know if anybody's in the room from NISE, but effectively NISE actually count per instance per application. So where this would be 1, in the previous example, this becomes 2. There really isn't anything else to count here. So whilst we would go through lots of contracts and have lots of descriptions about how this works, and what these terms mean and explanations, the reality is when you turn up as an auditor and you're confronted with this environment, there's only a limited number of things to count, right? So what we do is we drop that information into a database and we tag it. So we will say that a natural user netting policy, it has this here, the unit of count of natural user. We would consider something like, trying to think of an exchange, something probably like Deutsche Börse as being a unit of count of per instance, because you have to count the max count. So we go through and we tag this information. Once we have that data in a database with all of the metadata, we can start to combine that standardized rule set with internal knowledge bases. So this is the ACT example, which obviously I'm going to show ACT because that's one of our offerings. But the reality is this could be anything. This is effectively a knowledge base at the top here of how the applications consume market data. So you've gone to the application owners and you've built up an inventory effectively of what they're doing with the information and how they're using it. So you have your knowledge base. You can then feed that into a processor here where we drop in all of these pair rules. So everything that we just saw on the unit of count, everything on non-display use, everything on derived data use and so on, we feed in, and then we feed in the application answers, things like market data inventory and entitlement files. And what we can do is we can cross-reference all that information and we can actually then produce a shopping list of licenses that you've got to go and get effectively. But it all starts with that standardization. It all starts with making that information machine readable. In this example, this is automating the process of declarations. So similar idea. We've got various different inputs, inventory files, entitlements, so a DAX report, an EMRS report, HR files so that we can identify who somebody is. We normalize all that information. We put it into our rules management system. And then once again, we put the pair rules and client-specific rules in. So what's going on in that box in the middle, effectively, once again, is this standardization is saying, this exchange's unit of count is per instance, so I need to look at the max count. We have a netting, may have a netting relationship with a particular exchange. So I can use the HR file to identify a person, and I can net out that usage and pay for them just once. And what comes out the end of that is the various vendor-specific reports that we then send off to the customers. So that's where we are now. In terms of what we're looking to in the future, we've already got a couple of POCs running that we're playing with, and we're looking at harnessing effectively Gen AI. Which I'm sure people are probably fed up of hearing Gen AI already, and we're only at 10:20 in the morning. But the reality is it's coming. There's going to be a lot of advantages. There's going to be a lot of learning. So the way that the two areas that we've started to look at this is firstly providing a natural language interface to Pair. So Pair is an online knowledge store, so that it's the database, but it also has a GUI. At the moment, obviously, it works like every other GUI. You have to click around, you have to go and find the information. What we're using AI for is to build an interface which will be more like a chatbot. So we can have a conversation with the application and start to ask it questions. How much is this exchange? Can I use this data to derive an instrument, and so on? The second place that we're looking to leverage it is kind of more in our upkeep, I guess. So we obviously have to, as I say, look at those 56 documents that change every year, look at those price lists that change, analyze them, create summaries, work out what bucket to drop them in. So we're playing around at the moment with leveraging the AI to start to take some of that burden off of us. This is probably the most exciting bit, I think, because if we can do this for exchange contracts, it opens up a whole new world that there's no reason that we can't do it for other contracts. So we've always worked on exchange contracts because they are public and visible and standard. Is probably the most important thing. As much as people like to think that they managed to get something from an exchange that nobody else did, the reality is they didn't. They are standard contracts. But if we can get this to work for an exchange contract, we can then start to apply the same technology to broker contracts, to index provider contracts, and then we can start to do the same automation process. So in a bit more detail then, what is it that we're actually doing? So we're utilizing Microsoft Azure's OpenAI, and we've embedded within that this retrieval augmented generation. So we're not trying to build a model. We're not building a neural net. We're not planning on training data or training a model. What we're doing is we're using ChatGPT for GPT 3.5 and 4.0 for its strength. So effectively, we know that we have the answer somewhere within pair. That's the key. What we're trying to do is we're trying to create a discussion. So all we really want the AI to do is to look at that data in pair and put it into a human readable format so it's easier for the user to absorb. So effectively, what you have is you have the app, which in this case will be pair. The user makes a request that goes to an app server. And before you start sending it off to the AI, you could do that, right? We could give the AI all of the contracts and we could send it off to the AI and see what comes back. The reality is that everybody describes it as a feature for some reason of AI, but the reality is that nothing that happens here is repeatable. You could ask the same question of the AI and you will get a different answer almost every single time. So the way that we can focus the AI is by going to a cognitive search here and going and retrieving the information from pair to then provide the AI with a bit more context. So effectively, the path is input, server does it here, passes it to ChatGPT 3.5 to get context. We then take that context and use it to search our database. We then take all that information again and send it to the AI, and then the AI gives us our answer. The other kind of important bit here, which I think is going to become, I don't think it definitely is going to become an entire career soon, is coming up with specific prompts. So there's an art to actually asking a question of an AI. The more information you give it, the better the response. You also have to keep it on the rails. So you have to tell it what it is. You have to tell it what its purpose is. You have to put some safety guards around it to tell it not to run off and do something it shouldn't do effectively. We obviously don't want people, asking our AI to tell them a joke, for example. We want to keep it very specific to what it's doing. So that's all in writing these prompts here, which is something that Microsoft have spent a lot of time doing and that we're able to harness effectively. So what does that all lead to? So these are a couple of examples of kind of where we've got to. So we have two different versions of the AI running at the moment. One is focused on pricing, on data charge pricing. The other is focused on this digitization of contracts. So here we've got how much is UK level 1 data. The AI has gone away and effectively said, okay, these are the products I think you're talking about, or this is the product I think you're talking about. These are the variations of it. And then it's come back and given us a nice summary of what the various different costs are there for the London Stock Exchange. It understands that there's a difference in member and non-member. It understands there's a difference in per user and per instance. The key really with AI then is it's all well retrieving information. I mean, that wouldn't have taken many clicks anyway to find out what the price is of UK level 1 within Pair. But AI is very good at summarization. It's very good at doing maths effectively, a lot quicker than we are. So the real benefit is going to be asking it more complex questions. Once again, we're early in this process. This is pretty simple. But as an example, you could start to ask the AI what the price difference is between certain products. You can start to ask it what the advantages of certain products are. You could get it to price up what happens if I've got 50 of these users, how much is it going to cost me? So we start to be able to run these kind of queries effectively in quite a simple format. So on the contract summarization piece, we use the RAG architecture. And the reason that we're doing that is that we're injecting our learning. So what we're all going to have to make sure, I guess, is that we're adding value and we're doing more than just somebody chucking a load of contracts at ChatGPT, which any of us could pull ChatGPT up now, give it a contract and ask it a question. So that RAG architecture really is keeping the focus. So when we start to use this for the contract digitization, we're passing in a lot more parameters effectively. But this is a pretty simple example again. What's the delay period? And this is just on the LSE for it to be considered delayed. And we get this nice little summary here that explains, and then we get references for the documents back as well, so we can go and find where it's gone. Another example, going into the market data audit. So how, if an exchange comes and audits me, what could I be looking for? And we've chunked the documents and it's gone off and found this information to let us know that it's 5 years effectively, unless we've done something else. So a couple of examples of where we are, I guess. This is early days. We're probably looking at about Q3, I hope, to be able to launch the natural language interface on Pair, certainly the first piece on the pricing. And then, I guess we'll see where we end up in the future. So are there any questions? Oh, and of course, we all use AI to draw pictures, so that's an obvious one.
How would you determine the base and source for an answer? So I was just thinking, when you ask these questions, there are many options depending on different contracts. So would that be the magic of the prompt to narrow the question down that there can be only a specific set of answers, or how would you try to make the answering as informative as possible?
Yeah. So, yes, great question. So that's basically the beauty of the RAG architecture. So as I say, we could throw 20 contracts at ChatGPT and ask it a question about audit. And if somebody hasn't used the term audit, they've used something else, it's not going to pick it out. So the whole idea here is that we're injecting our learning from Pair. So we're injecting all of that standardization. So you're giving the AI a set of possibilities essentially to pick from. So once again, it's this dropping things into buckets and having metadata. The interesting thing is the AI doesn't do very well with structured data. Interestingly, you give it a table and the top, the column is price, the one here is currency, blah, blah, blah. It struggles with that basic kind of concept. So what we're actually looking at is having to turn that data into unstructured data, actually write sentences about it, tell the AI, this product is called UK Level 1 and it costs this amount of money if you use it in this way, and give it a sentence, and it does a lot better with that. But in terms of narrowing the focus, it's about giving it that standardization piece at the front. So you're effectively giving it some buckets that it needs to pick from.
Can I follow up the question? And it will only use the contracts that my company is interested in. So this is you will have a lot of answers and metadata tags in your database. But if I buy that product, it will learn what my company does have on a set of contracts, and then the answer will be limited to the contracts I have.
So initially, this first run will be an interface in pair, which is just exchange contracts, and it will be every exchange contract that we cover effectively. But you would narrow it down by telling it which exchange you're interested in. As I see the real power I see is that we can then hopefully use this software to absolutely do what you're talking about, go and digitize your contracts. And we can do it, the beauty of it is, without having to see them. So at the moment, we have lots of people asking, can I put my stuff in pair? Can I do this? These contracts are confidential. The index ones, it's a lot of time and effort. So using AI, we can take away that confidentiality piece because we'd never have to see it. We wouldn't have to see the responses. It would just be a system that's absorbing that information and digitizing it. Yes.
It comes down to natural user count. So would you maintain a cross-reference table, or would the user have to still maintain a cross-reference table? Because normally if you look at Bloomberg IDs and Refinitiv logins and whatever, so you need a cross-reference table. How is it going to be managed under the AI?
Yeah, so that's something we do now as part of the ADS service, which is a managed service. And what we tend to use is HR files. So it tends to be that a user has an ID, and then yes, we maintain a table which says this SID file and Bloomberg number and this ID is associated with this person effectively. It's a bit more complicated than that because a lot of the netting schemes have to be employees, they can't be contractors, obviously they can't be applications. There's all these kind of moving parts essentially in there. But yes, yeah, that's as part of that ADS service, we maintain those files.
How do you guarantee data security from the contracts uploaded to the AI capabilities and the rule sets created by the AI based on the company information so that it's not shared to IT?
Yeah, so that's something that Microsoft Azure does. So as I say, what we're doing here is we're not building a neural network, we're not building a new model, we're not teaching a model. We are relying on the public model effectively to just add nuance. So we're actually using the RAG structure to direct that. But Azure you have your own version effectively of the model in Microsoft Azure. None of it is used to train the public models. It's exactly the same as GitHub's Copilot when you're coding. You can have Copilot suggesting code, you can upload your code, but all of those things are shut down to your organization. Yes.
Everything that you spoke about is rather more about the public exchanges, but what about the other vendors, which are, for example, interview brokers or whatever third-party data providers? Because, for example, the number of contracts are really vast in that field for some clients. And do you intend also to expand the business also in that way, because public information isn't there for that?
Yes, yeah.
Are highly specialized. What about the analysis about these contracts?
Yeah. Yeah, say that's where we see the benefit of the AI because we can the reason that we don't do that at the moment and we do exchanges exactly what you said. It's public, it's standard, we can keep it up to date. What we see as the advantage of using AI to do this rather than people is that we should be able to deploy that solution to a customer and then we can actually run through a customer's specific contracts without having to see them. So it's the same, it would be the same learning, it would be the same use cases. There obviously need to be some variations in there, but the same idea of standardization and buckets, it's just that we don't have to see it. We're populating a database which is specific to a client. But that's probably 2025 onwards that we're looking at that. And we're starting with the stuff we can see. Excellent. Well, thank you very much. Oh, sorry.
Is there a way to get an explanation of what data is represented? Because I heard that usually ChatGPT makes things up. It doesn't know things exactly. So how do we make sure that it's actual data and actually from the source?
Yeah. So what we're doing is these literally here just say reference ... but effectively we're getting the API to give us a reference to explain, or the AI to give us a reference to explain why it came to that conclusion. So yes, AI is prone to hallucination. It likes to give a response even if it doesn't know. So it's prone to making something up. So that's all in the prompts. That's all in that engineering. And then here, bringing back the cross-reference so that we can check it effectively and make sure that it's giving the right information.
Two questions. If you're dealing with thousands of documents, how long does it take to train? Or actually, one. Question two, when you ask a question, what is the response rate for asking a question based on these documents?
Yeah. So when we're asking the questions, because of the RAG architecture, we're not sending the AI to the document. We're using a database where we've already standardized it. So the response time's pretty quick. It all depends on what you've signed up to in Azure. You can pay for your own specific instance. It will cost a fortune. Or you can go in a queue and it takes a little bit longer. And sorry, the first question was about the response rate of... So once again, we're not training a model. So we're not building a neural network and training a model. We're using the AI to populate a database, and then we use the retrieval augmented generation to inject that information to then create a summary. So it's not the traditional neural net of passing the data through and then forcing it back to change all the balances and so on. Yeah. Yes, precisely. That's the intention. Yeah, that we know that we're not going to the AI for its intellect. We're going to it to form the response and to look for nuance. So we know the answers in the database somewhere.
Jumping on exactly that point, I see that you're aiming to give us a natural language model where we can ask questions. Wouldn't it be an idea to pre-populate certain common questions into the interface? So we all know that we will have a set of 20-ish questions that we will ask, pre-populate them, for example, with a prompt or something.
Yeah, that's a good idea. Yeah, like an autocomplete or something. Definitely, yeah, that's a very good idea. Excellent. Well, thank you very much. Cheers. Thank you. I've got 20.